Welcome, ladies and gentlemen, to some Integrated 2 Math. In today's episode, we will be discussing Chapter 8.2.1, which is Angles of Polygons. Before we begin, if you could do me a favor, hit the pause button and copy down this table exactly as you see it, with the shape, number of sides, picture, number of triangles, and total angle sum. I think the last two columns are probably not going to make a whole lot of sense for now, but as we go through the examples, it'll start to make more sense. The first part of this lesson will be discussing how to find the total angles or the total angle sum of any type of polygon. And then from there, we will learn how to find out the angles of individual angles of the polygons, and then we'll figure out how to do the exterior angle of a polygon. Before we begin, also, I think we should probably define what a polygon is. A polygon is a plane figure with at least 3 straight sides and angles, and typically 5 or more. So take a second and copy down the polygon definition there. And from here, I think the table is really, the point of the table really is to make sure that we can establish a pattern about polygons and the angles inside them. So let's go and just fill out this table for a little bit. We're going to start with a triangle. It has 3 sides, obviously, and then a picture of a triangle. It doesn't matter what type of triangle you draw, but I'll go and just draw a triangle that looks like this. And then the number of triangles, obviously, is 1. And the total angle sum, well, when we learned about triangle angle sums at the beginning of the year, we learned that it was 180 degrees. So pretty straightforward there. The quadrilateral has 4 sides in it. Now, a quadrilateral we usually think of as a square, and for purposes of this, I'll go and draw a square. But it can be, you can draw any quadrilateral you want, and in fact, after this example, I'll do a quadrilateral where it still holds true. Now, the number of triangles, this is where things get tricky. What I'm going to do is I'm going to choose one of the vertices of this quadrilateral here. And when I mean a vertice, I mean one of the corners. It doesn't matter which corner I choose, but I'll go ahead and just pick a corner and draw a line segment that goes to another corner that is not adjacent to the corner that I have. So again, here's what I'm not doing. I'm not going to draw a line that goes straight up or a line that goes straight sideways, because I want to hit an opposite corner. Because what I've done is I've created a triangle. I've created actually 2 triangles. Now again, I told you that I would do an example of this that didn't have, that was not a perfect square the way we see here. So I'll go and erase this example real quick, and then I'll show you that it will hold true no matter what type of quadrilateral we have. So let's see here. Let's delete that real quick. And so I'm going to go and draw another type of quadrilateral here. I'll just go and draw one that looks like this. That's not square-like, and you can go and keep your square. It's no big deal. But it doesn't. Again, if I pick one of these vertices like this one here, this one up top, I'm going to draw a line that goes to another vertex, but that is not adjacent. So it'll be an opposite vertex here. So you see how no matter what example I use, I'll end up with 2 triangles here. This is triangle 1 and triangle 2. And so from here, there are 2 triangles in this model of a quadrilateral, a 4-sided figure. No matter which way I draw the quadrilateral, there will always be 2 triangles. Now from here, the angle sum, well, there are 2 triangles here, so I could actually assume that it would be 2 times the 180 degrees per triangle, giving me 360 degrees. A pentagon has, again, it's just one more layer up, so it'll be 5 sides. A pentagon, and for this purposes, I'm going to go ahead and just draw a regular pentagon. A regular pentagon has all sides being the same, like that, pretty much. And again, just like the quadrilateral, I'm going to go and pick a vertex. It doesn't matter which one I choose. Let me go and just choose the one on the side here. And again, I'm going to go and link up to the non-adjacent sides. Now, actually, what's funny is I could link up to the adjacent sides like this, but as you can see, it doesn't do anything. And so what we can see is we're gonna use this diagram to count how many triangles we have. Well, it looks like I've got 1, 2, and 3 triangles here, so it looks like I've got a total of 3. Each of those triangles' angle sum is 180, so really I have 3 times 180, which is going to become 540. And at this point, I'm hoping we're starting to see a pattern here. A hexagon has 6. Again, I'll go and just draw a hexagon real quick, like this. And then, again, I'll just choose one of the vertices. It doesn't matter which one. I'll choose this one at the top right corner. If I link up to this vertex, it doesn't do anything. But link up to this vertex, this vertex, this vertex, and then this one doesn't do anything. Count the number of triangles. There are 4 of them, which means 4 times 180 is going to give me 720. And from here, I think we can kind of see where this goes. A heptagon, I'm not really good at drawing, but there's 7 sides of them, and give me a second. I'm going to go find a picture so I can paste it into here. Give me a second. And here is our heptagon, a 7-sided figure, and I will do exactly what I did before. I'll go and just choose one of the vertices. It doesn't matter which one I choose. I'll pick that guy, and I've got one. Again, I'm just drawing segments that hit opposite vertices here. So we'll count how many triangles that produces. It's going to be 1, 2, 3, 4, 5. 5 total triangles, giving me a grand sum of 900 degrees. And again, that's because I've got 5 times 180. The octagon, 8 sides. And so from here, again, the octagon isn't terrible to draw. Anything after that, like the nonagon and stuff like that might be a little hard to draw. But actually, I'm thinking that we don't really have to draw so many of these figures from now on. I think that the pattern is well established. Your guess, and your guess will be appropriate. There are 6 triangles here. So 6 times 180 is going to give me 1080. A nonagon is 9 sides, and I don't know if we really have to draw this, because I think we're starting to see a pattern here. I think we're going to get that there's going to be 7 triangles, and 7 times 180 is going to get us 1260. And then a decagon has 10 sides, which means I'm suspecting that 8 triangles, and 8 times 180 is going to get us 1440. So, again, the total angle sum, let me just recap here. The total angle sum of a triangle is 180 degrees. 360 degrees is a quadrilateral. 540 degrees is a pentagon, so on and so forth. These are all total angle sums. And so the pattern that I'm trying to get you guys to see here by doing all these shapes, because eventually I'm going to ask you for a 70-sided polygon. In fact, I'll make that the last example here. So I want to find out the total angles of a. Actually, let's make the stakes even higher. Instead of 70 degrees, let's call them 90-sided polygon. The total angles of a 90-sided polygon. Well, what are they? Well, let's find out. If you notice, the number of sides in a triangle is 3. That resulted in 1 triangle. See the relationship. The number of sides in a quadrilateral was 4. That resulted in 2 triangles. See the relationship. 5 sides got you 3 triangles. 6 sides got you 4 triangles, 7 sides got you 5 triangles, and so on and so forth. So if I gave to you an n-sided polygon, then the number of triangles would be n, and I'm hoping you can beat me to this answer, it's n minus 2. And what we do to find out then the total angle sum is we take that n minus 2, which is the number of sides, minus 2, which is equal to the number of triangles, and we multiply that by 180. And that is the first formula that I need you guys to understand when it comes to this. That the total angle sum of any polygon is going to be the number of sides minus 2 times 180. Now from here, how does that help us to find the total angles of a 90-sided polygon? Well, if it's a 90-sided polygon, then we can actually go ahead and actually erase that question mark, because I think we can figure out what that is. Well, how many sides are in a 90-sided polygon? Well, it's 90. We subtract 2 from it, and then we multiply that thing by 180. So 88 times 180 means that there's 15,840 degrees total in a 90-sided polygon. So please understand this formula here, n minus 2 times 180. That will get you the total angle sum of any polygon. I'll be back with some examples. Alright, let's take a look at this example right here. What I want to do is I want to take this polygon here and I want to find out the total angle sum of this polygon, and then I'm going to find the measure of one angle. Now before we begin number 2, I'm going to go and put a star next to him, because there's a special attribute about this polygon that needs to be true if number 2 is even going to be possible. And they will always tell you that this is true about the polygon, but we'll talk about that in just a second. Number 1, if we're going to find the total angle sum, well, the first thing we want to know is how many sides do we have? So that means that the number of sides is equal to, if we count the number of sides, we should get 6. It's a hexagon. And so remember, the number of sides as we defined it in the last piece of this video here was n. So in this case, n equals 6. And if we want to do the total angle sum, then it would be n minus 2, or in this case, 6 minus 2, because that would get me the total number of triangles that were there, right? So this is the number of triangles that exist inside this hexagon. And I'm going to multiply that by 180. Again, why 180? Because 180 degrees is what creates a triangle. Now, just to hit it closer to home one more time, just because I'm a visual person, let's just make sure that there really will be 4 triangles in here, because 6 minus 2 is 4. That's 1 triangle, 2 triangles, 3 triangles, and I apologize for the lack of straightness of the line, but we got 1, 2, 3, 4 total triangles, which happens to be 6 minus 2 times 180. So 4 times 180 is going to get us 720. So again, 720 total degrees in this hexagon. So if they want us to find the measure of one of the angles, before we get into that, we need to first establish something. And this is always going to need to be true of the polygon that we're measuring. If they want us to find only one angle, the polygon needs to be regular. So let's talk about what a regular polygon is. A regular polygon is a polygon where all sides are equal measure and all angles are also equal measure. And that's what allows us to find the measure of one of the angles, because they're all going to be the same. So if we look at this, if we look at this this hexagon here, well, remember in the last problem we determined that there were 720 total angles in there, 720 degrees of total angle measure. But I want to make sure that I find the measure of one of the angles. Well, luckily, all of the angles are of the same measure. So what we do is we divide that by the number of angles that we have. And so how many angles do we have? Well, we have 6, which is also the number of sides we have. So we just divide it by 6, and we end up getting each one to be 120 degrees. So to find the measure of one angle in a regular polygon, so let's go ahead and get this formula down here. Finding the measure of a single angle in a regular polygon. Well, that's going to be n minus 2 times 180 over n. Alright, let's see if we can come back with another example. So we are back with our hexagon buddy again. I copied it and pasted him back. And so in the third question here, they're asking us to find the measure of one exterior angle of the hexagon. Well, in order to figure that out, and there's going to be a long way, we're going to do it first, but eventually it's going to become faster. In the last question, we determined that one of these angles is 120 degrees. Now, in fact, each of these angles is 120 degrees, but we really only need to pay attention to one of them because they're all the same thing. So remember, even though they're all 120 degrees, I'll pick the one that's visually the easiest. So I'll start with this version right here, this guy. Well, remember, if I'm going to find the measure of one of the exterior angles, the interior angle is going to help me, because what I can do is I can extend. I'm going to take the base of the hexagon and I'm going to extend him out like that and create that white line that you see being drawn right here. And what I want from that white line is I want this angle right here that I'm going to draw in sky blue. Well, luckily we can find that angle. That angle is going to be whatever's left when I take 180 and subtract 120 from it. Well, that's going to be 60 degrees. So one of the measures is going to be 60 degrees. And then, following up with that question, I'm going to ask the final question, which is going to be, switch colors back, find the sum of all exterior angles of the hexagon. Well, this should be relatively doable, because that white line that I extended out when I first found my first 60, that white line can be extended out here as well, allowing me to solve for this angle. And then it can be extended out here as well, allowing me to solve for this angle, and then this angle. And in fact, all of these angles, I'm going to end up with a total of 6 of these angles. So 6 times 60 will be 360. So let's talk about that for a second. Let me clean up the board. I'll be right back. So to finish this off, what I'm going to do is I'm going to go ahead and find out the measure of each interior angle here. All of these polygons are regular, and so that means that all of the angles will have the same measure. So this is an equilateral triangle here. This one I don't really even need to do. Each one's worth 60. We should know that by now. And over here I've got the regular pentagon. So again, I'm going to find out the measure of each interior angle first before I go to the exterior angle. So I'm going to go n minus 2, which is going to be 5 minus 2 times 180. And that's going to get me 540. But then I will divide that by the number of angles or the number of sides that I get, and that will be 108. So again, what does that tell me? That tells me that each angle is worth 108 degrees, and I'll just put them at everything. And then here, this is a decagon, a 10-sided figure. So just to show you that it's going to work for even a large-sided figure here. So again, 10 minus 2 times 180. So I'm going to go and figure out what that is. That is going to be 1440. But if I divide that by the number of angles I have, that's going to be 144. So 144 per angle. And I'm not going to write that 10 times, but I'm really just going to write that here, because I think what you guys are going to see me do, and I think some of you guys might see this coming, is I'm going to go and extend, and actually I'll switch colors that way it's a little bit brighter. I'm going to extend this angle out. I'm going to extend this angle out this way, and I'm going to extend this angle out this way to find the measures of the exterior angles. So from here, if each one of these is 60, well, what does that give me on the outside? That leaves me 120 degrees on the outside. So that gets me my total exterior angle here, my exterior sum, is 360. Kind of like the hexagon. Well, let's try the pentagon real quick. This one here, 108. Well, what's 108 minus 180? Well, that's going to be 72 degrees. But how many of those 72 degrees do I have? I have a total of 5 of them. And if I took 72 times 5, I would get 360 again. Exterior angle sum is 360, just like the equilateral triangle, just like the hexagon. Now from here, 144, exterior angle, 144. So 180 minus 144 will give me one of the exterior angles. It will be 36. How many of those exterior angles do I have? I have 10 of them. So 360 times 10, it is no secret. The exterior sum of angles is 360. Just like the regular pentagon, just like the equilateral triangle, just like the regular hexagon that we saw in the last example. So what I'm trying to get you to understand here is that the sum of the exterior angles of a regular polygon will always equal the same number and will always be 360. And I think that will wrap it up for this video. I will be back with some more examples on how to tackle these in a future video, and I will see you then.